Today we'll be looking at combinations. Our objectives will be to introduce combinations, to calculate a combination using the calculator, to look at an application using cards, and to look at an application using committees. So let's begin with the standard deck of playing cards, just to make sure we're all on the same page. If you're familiar with the standard deck of playing cards, you can forward through this part of the lecture. But for those of you who may not be, I have 4 suits. This one is what we call clubs, hearts, spades, and diamonds. 2 red suits, 2 black suits. These are your aces, and these are what we call face cards. They have people's faces on them. All the others are pretty much self-explanatory. Notice that in our deck there are no jokers, and so there are a total of 52 cards, 13 in each suit. So let's now look at a problem using a deck of playing cards. How many ways are there to draw a 5-card hand from a standard 52-card deck of playing cards? Well, let's say I'm dealing, and these are the cards you're getting. If the next hand I dealt, this is what you got, would you tell me that you have got the same cards dealt to you again? Is that the same hand? And the answer is yes, it is. What I want you to understand here is it doesn't matter what order the cards were dealt to you. This is still what your hand looks like. So in this particular problem, order does not matter. Therefore, this is a combination, not a permutation. If order matters, it is a permutation. In this case, order does not matter, so it's a combination. So the way we would calculate it would be the combination of 52 things taken 5 at a time. Hopefully you can figure out how to do that on your calculator. You enter the 52 first. Then when you go to the calculator, you do math, probability, but instead of NPR, you want NCR. Then enter your 5, and your calculator will give you 2,598,960. Let's look at another problem now. This time we'll be looking at a committee. How many ways can a group of 8 people select 5 people to serve on a committee? Once again, the question is, does it matter in what order I select those 5? And the answer is, it does not matter, so this is a combination. Once again then, it'll be the combination of 8 things taken 5 at a time. On your calculator, it would be 8 NCR 5, and then when you hit enter, you would get the 56. I do want to tell you one more thing about combinations. Sometimes you will see a combination written like this. It will have the 8 on top, the 5 on the bottom. You will not see the letter C at all, but when you see one written like this, it is a combination. Never will a permutation be written this way. I just want you to see that. Usually they're written like this, but occasionally you will find a combination written like this. Calculated the same way, it's just a different way of writing it. I just wanted to alert you, since the C does not appear, it's a little more confusing. Let's look now at another problem. How many committees of 6 can be selected from 6 women and 3 men? Well, what you should notice is that this right here really is irrelevant. It's just 9 people. So the real question is, how many committees of 6 can be selected from 9 people? Order doesn't matter. It's a combination. It would be a combination of 9 things taken 6 at a time, since we want 6 on our committee. The calculator would look like this, and we would get 84 for the answer. Now I'm going to change this problem just a little bit, and it is going to matter now about the women and the men. This time the question is, how many committees of 6 can be selected from 6 women and 3 men if a committee must contain exactly 2 men? And this is crucial now. You'll have to do this one in a couple of pieces. First of all, you'll need to select 2 men out of 3 men. Order still doesn't matter, so it's still a combination, and the first piece will be a combination of 3 men taken 2 at a time. That will give us 3. The next piece is I need to select the women. Well, if the committee contains exactly 2 men, how many women does it contain? Well, it has 6 total, so 6 minus 2 would leave me with 4 women. So I need a combination of 6 women taken 4 at a time. once again, when I do that on my calculator, here's what I get. You do need to know what to do with these two numbers. This is just like the car problem. You have 3 ways to select the men, and you have 15 ways to select the women. You need to multiply those together for a total of 45 different ways that committee can be selected. They don't get any more difficult than this in our combinations that we'll be doing here, so hopefully you're staying with me. You may need to practice these a few times. So that's all I have for combinations. I'll see you again soon. Bye-bye.